So if you've ever written any code at all, you've definitely used data structures, maybe without even realizing it. Today, we're going to pull back the curtain on these fundamental building blocks in JavaScript and really understand how it organizes all that data.
All right, so in our last explainer, we talked all about typecasting for, single values. But what happens when you're not dealing with just one value? What if you have thousands or even millions of them? Well, how you organize that data, that changes everything. And look, this isn't just some abstract academic theory. Mastering these concepts is what separates pretty good code from truly great code. It's absolutely the key to unlocking better performance, solving really complex challenges, and, let's be real, acing this critical coding interviews.
Okay, so let's kick things off with the most common tool in the entire JavaScript toolkit, the array.
So what is an array? At its core, it's just an ordered list of things. The first item is at index 0, the second is at index 1, and it just goes on from there. I love the analogy of a set of perfectly ordered shelves. Everything has its specific, numbered spot, and you know exactly where to look to find what you need.
But really, an array is way more than just a container. It's all about how you interact with it. You've got methods to add or remove items from either end, like push and pop. You've got tools to find stuff inside, like includes. And maybe most powerfully, you have these incredible methods like map, filter, and reduce that let you completely transform the entire collection into something brand new, usually without even touching the original.
Okay, now here's a super important concept you've got to get, especially when your arrays are full of objects. Arrays don't actually store copies of the objects, they store references. Think of it like a signpost pointing to where that original object lives in memory. And this can lead to some tricky bugs. It means if you copy an array and then change an object inside that copy, you might accidentally change the object in the original array too. So to avoid these headaches, the best practice is something called immutability, which is just a fancy way of saying create a brand new, modified array and leave the original one alone.
And for those times when you just need pure, raw speed, well, that's where typed arrays come in. Seriously, think of these as arrays on steroids. They're specifically designed for working directly with binary data, which makes them absolutely essential for high-performance stuff like WebGL graphics, browser-based games, or really anything that has to be blazing fast.
All right, so we've covered the basic toolkit. Now let's move on to the specialist tools. Look, arrays are fantastic. They're the workhorse of JavaScript. But that numbered index system, it's not always the perfect fit for every single job. So just think about this for a second. What if you needed to look up data by a specific label, not a number? Like a name instead of index 3. Or what if you needed to guarantee that every single item in your collection is unique? This is exactly where arrays start to show their limits, and it's why we need something a little more specialized.
And that brings us to a classic showdown in JavaScript, the plain old object versus the map. For a long time, developers just used plain objects for any kind of key value storage. But maps, they were built specifically for this job. They're way more optimized for frequent additions and deletions, they guarantee the insertion order is preserved, and here's their real superpower. You can use any data type as a key, even another object, not just strings.
And then we have the set. The best way to think about a set is like a collection of unique values. Its main job is super simple but incredibly powerful. It automatically gets rid of any duplicates for you. And it's also got this lightning-fast .has method for checking if something is already in the collection.
And this right here, this is the real aha moment for sets. You can start with a messy array. You see it's got duplicates in it. Then, with just one line of code, you pass it into a new set, and bam! Instantly, all the duplicates are just gone. It is seriously one of the cleanest and most efficient ways to dedupe data in all of JavaScript.
Okay, it's also worth quickly mentioning the weak variants, WeakMap and WeakSet. Now, these are more advanced tools, and they're all about memory management. Normally, if an object is inside a map or a set, JavaScript's garbage collector can't clean it up even if you're done with it. But these weak collections hold what's called a weak reference. This basically tells JavaScript, hey, if this object isn't being used anywhere else in the app, feel free to delete it and free up that memory. It's a really important tool for preventing memory leaks, especially in apps that run for a long time.
So, we've got these awesome ways to structure our data inside our application. But what happens when we need to send that data over the internet or save it to a file? Well, that's where JSON comes in.
Think of it as the universal language that lets our data structures talk to the outside world. JSON, which stands for JavaScript Object Notation, is pretty much the universal language for data on the web. And the key thing to remember is that it's just a text format. That means pretty much any programming language out there can understand it. So when a server sends data to your browser, or when your app talks to an API, you can bet it's probably speaking JSON.
And the whole process is really just a simple round trip. First, you take your JavaScript object and you serialize it. You turn it into a text string using JSON.stringify. Then, that string gets sent over the network. And finally, on the other end, the receiver deserializes it, turning it back into a real, usable JavaScript object with JSON.parse.
Now, here's a really common trip-up for developers. JSON looks almost exactly like a JavaScript object, right? But it's actually much, much stricter. The rules are tighter to make sure any system can understand it. For example, in JSON, keys must be strings wrapped in double quotes. You can't have functions or undefined values in there. And nope, no trailing commas allowed. These are the little things that can cause big headaches if you forget them.
Okay, let's zoom out for a second. We've got arrays, maps, sets, and JSON. We have all these fantastic ways to structure data. But so what? Why does this matter so much? Well, it all comes down to this. Data structures are the absolute foundation that we use to build powerful algorithms. You can think of it like this. The data structure is the strong foundation, and the algorithm is the incredible skyscraper you build right on top of it. You really can't have one without the other. And you can really see that connection here. All those fundamental algorithms for sorting, searching, and just looping through data, they're all built on top of arrays. When you need super efficient lookups or you need to manage unique things, maybe for something like a graph, maps and sets are going to be your best friends. Even more advanced structures like stacks and queues, they're often just built using arrays in a really clever way.
You see, choosing the right data structure for the job is a huge part of what separates good code from truly great, efficient code. And the next layer of mastery on this roadmap is learning how to analyze the performance of those choices. You start asking questions like, how does this affect how long my code takes to run, or how much memory it uses? That's when you get into the world of time and space complexity, but that's a whole other deep dive for another day.
So, we figured out how to organize and store our data, but that brings up a really fascinating new question. How does JavaScript actually decide if two values are equal? Well, in our next explainer, we're going to dive right into the tricky and sometimes surprising world of equality comparisons.
This is Developer Roadmaps. Map your path. Build your career.